In this video, we're going to take a look at multiplying and dividing complex numbers. So to begin with here, let's just recall some basic properties for complex numbers. Let's say we've got two complex numbers here, z1 and z2. So the modulus here of z1 times z2, that's equal to the modulus of z1 times the modulus of z2. Okay, that's our first property there. Now taking a look at the argument here, so I've got the argument then of z1, z2. So basically the argument of the product here of these two complex numbers, well, this is equal to the argument of z1, the argument of z1 plus the argument of z2. Okay, that's our second property there. So now if we take a look at the modulus here of the quotient, so z1 over z2, and this is equal to the modulus of z1 divided by the modulus of z2. Okay, and then finally here, if we've got the argument then, so the argument here of z1 over z2, in this case here, what I'm going to get is the argument of z1, minus the argument of z2. Okay, so hopefully you are familiar with these. These are our basic properties here, two complex numbers, z1 and z2. Okay, but what we're following on from here is working with exponential form. So now when we're working in exponential form, so for exponential form here, make a note of this here. When we're working with exponential form here, so let's define two complex numbers here. So we've got z1, put it up here, we've got z1, that's equal to r1 e to the power then of I theta 1, like so. And we've got z2 here, our second complex number. So z2 is equal to r2 e to the power of I theta 2. Okay, so from here then, my product now, so z1, z2, that's equal to r1 times r2. We get r1 times r2 there. Then we're going to get e here. So we get e to the power of I times theta 1 plus theta 2. So theta 1 plus theta 2 there. Okay. That's our first property there when working with exponential form. And then if we're dividing here, so let's say we then got z1 over z2. And in this case here, what we've got is r1 over r2. We times this here by e to the power of I theta 1 minus theta 2 there. Okay, and there we have it. So like you can see, these are properties here for multiplying these two complex numbers when working in exponential form, and then dividing two complex numbers here again, just working in exponential form. So that's our introduction there for multiplying and dividing complex numbers when working in exponential form. So what we're going to do now is just take a look at some practice questions here for multiplying and dividing complex numbers. Starting off with question 1 now, what we want to do here is express this product of these two complex numbers that are expressed in mod arg form in exponential form here. So to begin with, what I need to do then is convert both of these complex numbers here into exponential form. So if we begin here with two lots of cos pi over 3 plus I sine pi over 3. Let's just begin by writing that down. Pi over 3 plus I sine pi over 3 here. Then writing this in exponential form here, so just remember exponential form is re to the power of I theta, where r here is the modulus, so the modulus here is 2. And then theta here is our argument, which in this case is pi over 3. So we get 2e power of pi over 3i, so pi over 3i there. Doing the same now for this complex number here. Got 4 lots of cos pi over 12 plus I sine pi over 12. Okay. So again here, we express this now in exponential form. So my modulus here that would be 4. We get 4e. And then my argument here is pi over 12, so that's going to be 4e to the power of pi over 12i. We get pi over 12i there. So now, what I'm going to do here is express this product now in exponential form. So therefore, what we've got here is 2e to the power of pi over 3i times 4e to the power of pi over 12i. Okay, so now when we multiply these here together, we're going to get R1 times R2, so 2 times 4, which would give us 8. We get 8 here to begin with. Okay, and then now what we do here is we simply add these powers together. We're going to get 8e power here of I times pi over 3 plus pi over 12. Okay, so pi over 3 plus pi over 12. To perform this addition here, obviously we need a common denominator. I times this fraction here, this pi over 3 by 4. I get 4 pi over 12 plus pi over 12. In total there we get 5 pi over 12. So in this case then we get 8e, the power here of I times 5 pi over 12. Which in this case we can simply write as 8e power then 5 pi over 12 I. Okay, and there we have it. So what we've got there is we've got it in exponential form, re the power of I theta. We've got it in that form there, and there we have it. So that's the solution there to question 1. And finally then, if we take a look at the very last question here, question 2, we've been given 2 complex numbers. So we've got z1 and z2. Those we begin with here, we're asked to express z2 in exponential form. So the complex number here, z2, is 1 plus I. So in this case then, if we want to express z2 in exponential form, we need 2 things. We need the modulus here, which would give us r, and we also need the argument here, which would give us theta. So for r here, this is the square root of 1 squared plus 1 squared. And in this case here, this would give us the square root of 2. So hopefully nice and straightforward. And then for the argument here, over theta, this would be tan inverse of 1 over 1, which is simply 1. We're taking tan inverse here of 1. And working in radians then, this would give us pi over 4. Okay. We've got everything that we need here now to express z2 as complex number in exponential form. So therefore, z2 is equal, so it's going to be re, so r is root 2, so we get root 2 times e, and our power here is I times theta, so theta is pi over 4, we get pi over 4 I there. Okay. And there we have it. So that's the solution there to part A. So that's the complex number z2 in exponential form. If we take a look at B now, we're asked to find z1 times z2, given our answer in exponential form. So because we've now got z1 and z2 both in exponential form here, finding the product of those 2 complex numbers is quite straightforward. So for z1 times z2, we now use their exponential form here. So z1 is 4e to the power of pi over 2i. So 4e to the power of pi over 2i. And then we times that here by z2, which is root 2 e to the power of pi over 4i. So now when we multiply these together here, we get r1 times r2. So 4 times root 2 would give us 4 root 2. And now for the powers here, we simply add these together. So we factor the I out, so we're going to get e, the power here of I, times pi over 2 plus pi over 4. Okay. So if we evaluate this bracket here, pi over 2 plus pi over 4, well, what I need to do here is get a common denominator. That would be 2 pi over 4 plus pi over 4. That would give me 3 pi over 4. Okay, so what we're going to get here is 4 root 2 e, and then to the power here of 3 pi over 4 I. Okay, and there we have it. So that's the solution there to B. And then finally here, over part C then, we have to find this quotient here of Z1 over Z2. So Z1 over Z2. And this time I want to give the answer in the form x plus iy, where x and y belong to the reals. So in other words, x and y are just real numbers. So to begin with here, let's just express Z1 over Z2 here. So Z1 is 4e to the power of pi over 2i. So 4e to the power of pi over 2i. And then we divide this here by Z2, which is root 2 e to the power of pi over 4i. So root 2 e to the power of pi over 4i. Okay. So now when we're dividing complex numbers like this here, what we're going to get here is r1 over r2. We're going to get 4 over root 2. We then get e here. And then my powers, what we're doing here is this power minus this power. Okay, so we can factor the I out again. We get I lots of pi over 2 minus pi over 4. Okay, so pi over 2 minus pi over 4. Again, to perform this subtraction here, we need a common denominator working with these fractions. This would be 2 pi over 4 minus pi over 4. That would simply give me pi over 4 there. Okay, so let me just write this underneath. I'm just thinking about the amount of room we've got here. In fact, let me just get rid of this solution here for B. Just so we've got enough room here to finish this question off without confusing this and mixing it up with B here. Okay, that'll be plenty of room here. So, like we said, pi over 2 minus pi over 4, that would be 2 pi over 4 minus pi over 4. So it'll give me pi over 4 here. So we'll deal with the 4 over root 2 in a moment. We get 4 over root 2, e, and then this would be to the power here of pi over 4i. We get pi over 4i there. So now we need to deal with this 4 over root 2 here as well. So what we can do here is just rationalize. Okay, 4 over root 2. What we can do then is times the numerator and denominator here by root 2. We're going to get 4 root 2 over 2. And we've got e to the power pi over 4i. And in this case here, 4 root 2 divided by 2, that would give us 2 root 2. We get 2 root 2 there, e to the power of pi over 4 I there. Okay? Now at this point here, we're not done, because what we've got here is exponential form. Okay? And that's not the correct form that we're asked for here. Okay? So now what I want to do then is express my solution here, this complex number that we've got. So this is an exponential form. What I'm going to do now is express this here in mod arg form. Okay, so let's just box off what we've got here for A. We take this to the top here. So writing this now in mod arg form here. So writing this in the form of r cos theta plus I sine theta. And what we're going to get here, so my r is 2 root 2. I get 2 root 2 here on the outside. We then get cos of theta. So remember, theta here is the argument, or in this case, my argument is pi over 4. we get cosine here, pi over 4, plus I sine pi over 4. Okay. So at this point here now, cosine of pi over 4 and sine of pi over 4, well, we can simplify those. If we know those exact values, then we can simplify this quite nicely as well. So we've got 2 root 2. We get 2 root 2. We then got cosine of pi over 4. That would give us 1 over root 2. We get 1 over root 2. We've got I sine pi over 4. Well, sine of pi over 4 is also 1 over root 2. We get 1 over root 2i. So now if we multiply through here, 2 root 2 times 1 over root 2. Well, in this case, that would give me 2. So basically what I'm getting here, if I do it in full, so I'm going to get 2 root 2 over 2. Like so. And we get the same here, but with I as well. We get 2 root 2 over, sorry, so that should be over the square root of 2 here. Let's not make that mistake. And don't forget the I. And in this case here, clearly the square roots will cancel. So what I'm going to get then is 2 plus 2i here. Okay. But you can see there was quite a bit of work here for C. But there we have it. So 2 plus 2i there is our solution. So x and y would simply just be 2 there. Okay. And there we have it. So that's the solution to C there. That gives the solution there to the second question. And that brings the end of this video on multiplying and dividing complex numbers in exponential form. So in the next video, we're going to take a look at de Moivre's theorem.